Ah, poo. Happy Halloween! And good job for clicking on this video. If you click on this video, that means you're worried about the quiz tomorrow and you want to study, so let's study. One of the first things we need to go over are our historical astronomers. Let's start with Ptolemy. He believed the Earth was the center of the universe. Now, this was not correct. The Earth was definitely not the center of the universe, but this became the most popular theory for 1,500 years. It wasn't until Copernicus came along that people in Europe started to realize that Ptolemy was wrong. Copernicus believed that the sun was the center of the universe, and it revolutionized astronomy in Europe. Thank God it did. China, India, and a lot of people in the Middle East, including Persia, were already way ahead of this. They knew Ptolemy was wrong. But it wasn't until Copernicus that the rest of Europe realized that the sun was actually the center of the universe. Another couple of important people here. We've got Galileo. Galileo was the first person to observe space through a telescope, and he managed to show that the other planets were like Earth. At that time, they believed the other planets were just wandering stars, and that's not true. He was able to distinguish between stars and planets when looking at the night sky. He also discovered the moons of Jupiter and of Venus. Then we have Mr. Hubble. Mr. Hubble discovered that there's other galaxies besides our own Milky Way. And thanks to that giant discovery, he got one of the biggest telescopes of all time named after him. This telescope is in space. That's where it stays, and we use it to observe everything out there in the universe. We get a clearer picture because we don't have to worry about light pollution when we're out there. If we're looking at our own galaxy here, our sun is here. That means our planets are going around this little dot here, and we are here in our Milky Way galaxy. Now, let's go over some other basic terms that we need to know before we jump into talk about constellations. Some other basic terms are, sorry, I'm looking for that slide right now. I'm stalling real hard. Good, here we are. Astronomy. We're studying astronomy, we need to be able to define it. Astronomy, simply put, is the study of the universe. Anything in the universe that we're studying is going to be called astronomy. Now, if I'm talking about outer space is an American term. We're really talking about the physical universe beyond the Earth's atmosphere. Anything outside of the Earth, we're going to call out of space. Two more or three more basic vocab terms here. We've got exploration, moon, and kind of satellite. We need to talk about those words. Exploration is pretty simple. Exploration is something you all have done this year. Exploration is when we go somewhere new and we learn about it. All of you have come to EF, come to New York probably for the first time, and you've come here to learn. You're exploring it. One of our other vocab words is the moon. The moon is a natural satellite. That means the moon revolves around the Earth. The moon revolves or spins around the Earth. Now, if I say the moon is a natural satellite, I also need to tell you what a satellite is. A satellite is anything that orbits around a larger body. It is anything that revolves or orbits or spins around a larger body. Satellites can be man-made, like our GPS satellites or the ISS we have up here, or they can be natural, meaning things like the moon. Earth could be considered a satellite, the sun. Anything that we didn't make, anything that existed. Alright, so there's a couple of basic things that we need to realize here. Why is it important to tell time in the past? It was for food. Honestly, the way we told time was through looking at the stars, through looking at the sky. The three important things about time that we need to know are these three words: year, month, and day. A year is how long the Earth takes to orbit around the sun one time. Once the Earth Earth goes around the sun one time, that's a year. So here we go. I'm going to make a little sun. Ooh, look at the light. Good light. So here's our Earth. One time around the sun is a year. So one time, the Earth going around the sun one time, that's a year. A month is how long it takes for the moon to go around the Earth. A month is how long it takes the moon to go around the Earth. Then a day is how long it takes for the Earth to spin one time. How long it takes the Earth to spin one time. That is a day. Those are three important vocabulary words when it comes to time. Make sure you're familiar with those. All right, now that we have the basic vocab out of the way, let's talk about constellations. So, constellations are groups of stars, and they form patterns in the night sky. Now, the patterns are not set in stone. Depending on where you're from or what your culture is, you might see different pictures. The picture I always like talking about is the Big Dipper. The Big Dipper I don't see up here at the moment, but the Big Dipper here in the States is seen like a big spoon. In Europe, it's seen as a bear. It's called Ursa Major there. And in other countries, it's seen as a horse. So it depends on what culture you're from. People will see different pictures. But at the end of the day, constellations are just a group of stars that form some sort of pattern in the night sky. Technically speaking, there's 88 officially recognized ones. They're recognized by the International Astronomical Union. Now, when it comes to constellations, some you can only see from the southern hemisphere. Some you can only see from the northern hemisphere. Some constellations you can only see during the year, during the winter. Some you can only see during the summer. Some you can see at all times of the year. So depending on when you are and where you are, you can see certain constellations. So oftentimes with these constellations, there's stories associated with them. For example, this is Orion, Orion the Hunter. One of the stories associated with him is that he's hunting Taurus, which is another constellation near him. Taurus is a bull. So the story associated with him is that he's hunting the bull next to him. Another story is that Orion is a hunter that is chasing after 7 women known as the Pleiades, which is another constellation, which is a little further here to the right, is not in the picture. Constellations have all sorts of stories associated with them. For the quiz, you don't need to know all the stories, but do know that constellations are used to tell stories. They're used for navigating, and they're used to find other stars. Alright, so that is all I have for you on constellations. So let's get to the stars. Our sun is a star. Believe it or not, our sun is a star, and it's close to Earth, which is why it's the brightest and biggest star that we see. Now, other stars are very small because other stars are very far away. Our sun is close. Now, our sun might be big and bright to us, but we have to remember, looking at this chart down here, our sun is actually not the biggest star there is. There's definitely bigger stars out there, and even brighter stars like Sirius, the brightest star in our visible sky. Now, the sun creates energy for itself. It's so bright because it creates energy. And it gets this energy from fusion. So what the sun does, it takes this hydrogen atom, and it takes this hydrogen atom, and smushes them together really fast and under really high temperatures. And when it does that, it creates this energy that comes off it. So this is fusion, and fusion happens in the core of the sun, and it happens a lot of times a second. In the core, it fuses up to 620 million tons of hydrogen gas a second, and that produces a lot of energy. Here's another little GIF of it. We have the hydrogen atoms fusing together, and that creates energy. Now, the sun is creating a lot of energy, but what's holding all that energy in is gravity. Gravity holds all that energy in. It keeps the sun from exploding. Now that we know a little bit about the sun, let's look at the life cycle of our different stars here. We're going to start with the youngest kind of star that we have. It's a nebula. A nebula is just a giant cloud of gas and dust that's just kind of floating here. I'll play the video for a moment so you can see different nebulas. Nebulas, honestly, are very pretty to look at. They're just gas and dust. They're incredibly colorful. A lot of these gases are elements. When they're heated up, they tend to glow certain colors. So, they're incredibly pretty. Alright, I managed to make this big. That's not what I meant to do. It's good to know I'm still bad at technology, even while I'm filming myself. So, that's a nebula. After a nebula, we have a protostar. A protostar is when we have the gas of a nebula starting to be sucked into one spot. Now, this spot here is more dense than the rest of the nebula cloud. And when that happens, we start to create a little bit of heat in the center because we have more and more gas coming to the center. And getting more and more gas towards the center kind of heats it up and becomes more bright. And when it becomes more bright, it gets more gravity and it brings in more gas, and more gas in the middle makes it heavier and more dense. That increases the gravity even more. That pulls in even more gas. Slowly, we're going to get all this gas that's being spun sucked into the center. And that heats up the center and starts to create this light. Now, when all this is done, when a protostar is done sucking in all that gas, it's going to create a main sequence star. A main sequence star is when we have fusion begin to happen. We have our hydrogen molecules or hydrogen atoms being smashed together to create helium that's creating energy for the sun. And our sun is a main sequence star. And it's going to create energy through fusion for billions of years. Now eventually, what will happen to a main sequence star, because it's going to keep growing, two things are going to happen. It's either going to become a red giant or a supergiant. A red giant and a supergiant are both bigger than our sun, but it depends on how big the nebula was. If the nebula was only a tiny nebula, our main sequence star is going to become a white dwarf star. If our nebula was really big, our main sequence star is going to become a supergiant. So it all depends on how big the nebula was. Now, eventually our sun is going to turn into a red giant, and when that happens, it's definitely going to destroy Earth. But that's not for billions of years. Now, white dwarf stars are what main sequence stars become if the nebula was small, and that's just the core of the sun that's left. It's slowly losing energy and heat, and it glows white. Supergiants, however, keep going bigger and bigger and bigger and bigger, and when supergiants get to a certain size, they are going to explode, and that's called a supernova. Sometimes these supergiants keep growing, and when that happens, it looks like they're about to explode, but then all the gravity from this giant massive star sucks in all the light. And when that happens, we have a black hole. Black holes are incredibly massive, and nothing can escape them, not even light. The gravity is so strong it even affects time. Wow. Alright, I have spoken a lot, and that is the end of the video. Hopefully it wasn't too fast. I know I've covered a lot of information, but that's it. Good luck studying, and if you have any questions, please feel free to email me. Good night, everyone, and happy Halloween.